Okay, hi guys. So, in this video, what I want to go over is just college algebra review mostly. Give me a second while I open, or that was not the one I wanted to open. Hold on, guys. Okay, so I want to do a review of college algebra, just in general. And rather than do a stream about it, I want to just do a whole video explaining, like, very briefly, just everything, like, going over examples, you know? I'm not going to really be doing, like, a whole lesson here where I'm, like, explaining what the vertex is, explaining what, you know, what is what, because that'll just take very long. I'm just going to do a brief review, and they're mostly going to be problems that, you know, that are from other parts, like from other websites or, you know, from books. The first thing that I want to focus on is a function. So first I'm going to actually title this. Hold on. So okay. So the first thing that I want to focus on is functions. So what is a function, right? And I think I went over this like a long time ago when on my YouTube channel, like I went over this. So a function, think of it as a machine, you know, as an input and then output, right? You put one thing in, so basically think of it kind of like a little machine, right? You put one thing in and then you get something out. This is an output. So for example, if we have something like, I don't know, let's just say we have like a little, you know, this is like a little container, right? And this is kind of like how they kind of defined it, or made this analogy basically, where if we have a function, or if we have an input x, and you know, this is kind of the machine. And I know this is a really bad drawing, but you know, this is a machine, and we have something like, this is our function f of x, and then we're gonna have our y values, so it'll be something like this, right? Now, f of x and y are the same thing, but what I mean by f of x, it's mostly an equation, and this is mostly so this is a coordinate, or like the y value. It's a value. It's not really an equation, it's a value. This is the equation, and this is the input, right? And so for example, if I have f of x equals 2x minus 3, and I say, oh, I'm gonna do, like, for my input, I want to do 1, right? Well, what we're gonna do is we're gonna go ahead and plug that in. So this is 2x minus 3, and then this would be our y value, right? So we would have something like 2 times 1 minus 3, and then 2 minus 3 is negative 1, right? So our y value would be negative 1. So it'd be, if you plot it, 1, negative 1, right? That's the meaning of a function. It means that it's, you know, it's basically you put something in, you put a value in, an x value in, any value. It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, anything, and you get something out. That's what a function is. And there are different kinds of functions. Number one is a linear function. That is of the form y equals mx plus b, or y minus y1 equals m times x minus x1, or ax plus by equals c, right? So that's one. Second one is a quadratic function. That's what is it called? That is ax squared plus bx plus c, which this is the standard form. And then we have a times x minus h squared plus k, which this is the vertex form. Now, there are two things that you want to notice with this one. The axis of symmetry is x equals h, and then the vertex is hk, right? We'll go more in depth on that once we get there, but the basic thing that you want to know is that these are the two different kinds of, ways that you write a quadratic function. A polynomial function is of the form, so how do I say this? So a quadratic function is a polynomial function, but a polynomial function is of degree, basically it's of degree n, so basically you have ax to the n plus bx to the basically the best way to explain what a polynomial function is, there's a whole form of it, but I don't want to confuse anyone here because obviously it's I don't want to confuse you guys. I really don't. There's a whole form of it, and if y'all really want me to, I can say the whole form, but we don't have to know. You don't have to memorize that form. So give me 1 second. Okay, so a polynomial function. I'm gonna just write the form down, but like I said, guys, please don't get overwhelmed. You do not have to memorize how this is. So a polynomial function is f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus ... plus a sub 1x plus a naught, or a sub 0. A naught, basically. So that's the form of a polynomial function. One of the things to know is that basically just know the fact that okay, a sub n is one thing, and so basically if I have, okay, oh, how can I define this one? Hold on, guys. So the way they're thinking about this is in sequences and series, I believe, because a sub n is a real number. If we have a0, that's the 0th term, so basically real number, and then where n is the nth term. You don't have to know, like I said, you don't have to know this. This is just very brief, but just know that a polynomial function just means that you have a think of it as any function with more than 3 terms. So basically, for example, Like, not more than 3 terms, but like, it's honestly any function with any nth term. Basically, what I mean by that is, as long as it's of the form ax to the n, then it is a polynomial function. Okay. So, as long as it's of this form, if I say like f of x equals 2x cubed, yes, that is a polynomial function. F of x equals 2x minus 1. Yes, that's a polynomial function. F of x. And it can be f of x equals a x to the n plus c. Two, meaning that c is any real number. Okay. Sorry, guys. Okay. So, yes, this is a polynomial function. A linear function is a polynomial function. If I have 2x to the 9th, if I have f of x equals x cubed minus 3x plus 1, if I have f of x equals x squared plus 2x minus 1, these are polynomial functions. Now, when it is not a polynomial, that is when you have something like a square root or an absolute value, some kind of weird sign where you're like, okay, you know, it doesn't matter. Like, if I said, oh, f of x equals x to the something plus x to the something plus x to the something, like, yeah, this is a polynomial function. Yes, it is. Now, that is another kind of function. So the other kind of function also is a rational function. Now, this is not a polynomial function. This one is of the form, so you have 2 forms. You have 1 over the quantity x minus h plus k, or ax plus b over cx plus d. These are 2 forms. Okay. Now, let me write this better actually. F of x equals ax plus b over cx plus d. Okay. Where cx plus d cannot equal 0. Where x minus h cannot equal 0. There's a reason for that. Because you can't have undefined on your graph. You can't have 0 on the bottom of your equation, because if I said, for example, if I said, oh, f of x equals 1 over x minus 3, and I say f of 3, is f of 3 defined? 1 over 3 minus 3, that's 1 over 0, nope, that's undefined. How would we graph 1 over 0? We can't. That's undefined. If you answer it on your calculator, it's going to be error. So it's not defined, so you don't put anything. Then the other one is square root function, so that means the square root of x minus h plus k f of x equals, and let me go ahead and do a little sketch of how each of them looks. This is the parent function f of x equals x. For the quadratic function, the parent function is f of x equals x squared, so you're going to have something like this. A parabola. We also know like parabolas, like that's a common term. Right? For polynomial functions, well, if you have a cubic function, for example, that's a polynomial function. A cubic function is a specific kind of polynomial function where we have something like this. And that's kind of a crappy drawing, but it's okay. A rational function looks, the parent function for that looks, oh, how does it look? It's, like this. F of x equals 1 over x, okay? Give me a second, guys, hold on. Okay, so, the square root function, that's, okay, so yeah, this is f of x equals 1 over x, right? That's a rational function. Notice how when I do 1 over x, I don't have anything for 0. In other words, I don't have a y-intercept. That's because f of 0 equals 1 over 0. That's undefined, okay? So that's how that works. A square root function, if I do f of x equals the square root of x, you get something, let me think. Like that. And then there's also the exponential function. Now, the exponential function is, so the parent function for that is e to x. This is, I mean, I don't know whether to call this a power function, because a power function is different. A power function means that you have something to the x power. If you have 2 to the x, 3 to the x, 4 to the x. But it is also exponential. So I guess you can call an exponential function a power function, but this one specifically, like e to the x, I don't think that would be a power function. I mean, it is. Actually, no, it is. It is a power function. So an exponential function, if we have 0, 1, we go like this, basically. And, okay, that's a terrible representation. Let me go ahead and, not that I forgot how it looks, I know how it looks. But I just have to make sure. Give me 1 second, guys. Okay, I got it. So it looks like this. So basically you have your 0, 1 here. And you're going, so it looks like this. And just keep going up and up and up, right? And that is f of x equals e to the x, okay? Now, the difference between that and a power function, and maybe I can show you guys how it specifically looks. Hold on. Sorry guys, give me a second. I have to look. Hold on. Okay, so if we look at e to the x, or let's look at a function of the form a to the x, right? If we move this around, it gets narrower, 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 narrower. And then if we if we go like this, well, okay, obviously, yeah, we're not gonna have that, but if we do something, if it's less than 0, basically, like if it's less than 0, or if it's less than 1, excuse me, we have something, we have exponential decay, right? If we have more than 1, we have exponential growth, okay? That's how it works. That's the difference. E to the x is very special. There's a difference between, and I will go over those. So number 7 is a power function, specifically a to the x, where a does not equal 0, so it can be of the form f of x equals a to the x minus h plus k power, or x minus h power plus k, and then you have where a does not equal 0. Okay, that is how it's written. Let's see. Another one. I would say the cubed root function, but I really don't know about that one. I mean, there's also the nth, like, the rule of, like, and I will go over, like, square root rules and the nth root rules, right? Because there's also functions for that. Since this is just college algebra and not trig, I'm not gonna go over trigonometry, only because, I mean, yeah, I do have a whole playlist on trigonometry if y'all want to look at that, but I'm not going to go over trigonometry for this review, because this is college algebra, it's not trigonometry. If, you know, unless you're doing algebra 2, yeah, you can go look at my trigonometry, but when I was in college algebra, I did not do trigonometry in that class, so, I mean, I don't really understand why they would want you to learn trigonometry in algebra 2, but every teacher is different, every school is different, so. Okay. So, those are the kind of functions, and also, I forgot to mention, there's also, number 8, f of x, so logarithmic functions. So that's like, I forget how these look. I always forget how these look. These are very, because there's a difference. Like, there's logarithmic functions in general, like, you know, like the log-based something of something. So I'm gonna just color code really quick. This is a logarithmic function. This one is f of x equals log of x, okay? Now, there's this one, and then there's also number 9, the natural log function. This one is different. This one, I mean, it's not really that different, but, for example, like, so if I go ahead and graph it, if I do log of x, so log of x, this is log of x, right? If I do ln of x, that's ln of x, or natural log of x, rather. If we do 10 to the x, you see how, like, okay, so for example, this is 1, 0, or let me just go ahead and do a point. So 2, 0.301. Okay, that is right here. Right here. And we're gonna label it. Now, let's just switch that. 0.301, comma 2. You see how this one, you see how they're reflected, kind of? That means that it's an inverse. So basically, log of x and 10 to the x are inverses of each other. Okay? What that means is that when we let's say we were to graph the linear function f of x equals x, it means that they are reflected across this line f of x equals x, right? Now, inverse, that is another topic that I will go over, but that's kind of the difference between natural log functions. Natural log just goes, natural log goes a little higher than normal log. It's the same, kind of the same thing, but so like if I say log of 1 equals ln of 1, okay? But log of e does not equal ln of e. Does that make sense? Like, you want to remember, not that you want to remember those, but you want to know the difference between both of them. Log of x is just the inverse of 10 to the x. It's log base 10 of x, really. That's what log of x is log base 10 of x. So that means that if we were to write this in exponential form, it would be log base b of y equals x if and only if b to the x equals y, okay? We'll go over that very in depth soon. I don't want to spend too much time trying to explain the definitions, but this is what we're going to go over in this video, all of this stuff. And if I don't do it in this video, it will be I'll do parts. So let me see how long I've been recording for. 28 minutes, okay. Enough of me rambling. Let's just get started. I've defined everything that I needed to define. And also, in this video, we're going to do conic sections. That's another thing. So, like I said, I'm going to do it in parts. Once it hits 50 minutes, that's when I'll stop the video, and then I'll do another part. But, yeah. So, let's see here. Linear equations, right? So, okay, and So if we have something like 2x plus 3y equals 4, this is a linear equation, right? In standard form. Now, there are problems where they tell you, for example, there's this, and then there's also, let me just go ahead and define really quick, slope-intercept form. Slope-intercept form, that is very, very special kind of equation, or form of a linear equation. You use it a lot in algebra. A lot, especially when you're doing linear equations, and it follows, like, honestly, you know, the y equals, so basically y equals mx plus b, that is the most basic equation in all of algebra. In all of algebra, I will say that right now. It is the most basic one. And if you don't know what it means, then you really need to learn it. Because moving forward, you really want to understand, you know, once you can learn quadratics and stuff, you want to understand what it means. So, the slope-intercept form is y equals mx plus b, where m does not equal 0, x does not equal 0, b does not equal 0, okay? I'm trying to think. Also, there is also, before I get into functions, there's also a thing called interval notation. We're also going to go over that. That's actually the first thing I'm gonna go over. Let me go ahead and do that first, actually. So, interval notation, right? When we have something like a is less than or equal to x is less than or equal to b, this is written as, so this is graphed actually as something like this, right? You have a number line, and then you have from a to b, right? You're gonna do a closed circle, a dot, okay? Because when you have something like this, this is a dot. When you have something like this, it's a dot. When you have this, it's an open circle, and when you have what this is, it's a closed circle. Now, a lot of people tend to forget, and it's okay if you do. It, you know, I know that for me, like, even when I was in algebra, I literally forgot what it meant whenever it said, oh, less than or equal to, greater than or equal to, less than, greater than. I forgot what each one meant, you know? So it's okay if you don't understand what those mean. Don't beat yourself up about it. A lot of people forget. So this one, this one in particular is less than, okay? You always want the little alligator, or the little Pac-Man, if you want to call it that, to, like, to be eating the greater number, because he wants to eat more. Think of it that way, right? So let's say we have something like 7 is less than 8, right? Or 7, and then this, and then 8, right? Because he wants to eat the bigger number. He wants the bigger number. Because he's hungry, he wants the bigger number, right? This one is greater than. Now, don't get confused when it's saying, like, seven something and then this to 8. Don't get confused, because this just means 7 less than 8, okay? This one means, so I would say 8 greater than 7, right? That's what it means. Now, an equals to means 8 is less than or equal to 2. So, like, it can be less than or equal to, right? This one means less than or equal to, okay? This one means greater than or equal to, okay? So, if I'm doing this, think of this as a little, like, you're going from left to right, okay? A is less than or equal to x. This entire part is x is less than or equal to b, right? I'll color code it. And let's just say that this is A and then this is B, okay? Just so that, you know, y'all can understand what I'm talking about. So this x right here, you're going to go from A to B, right? So then it's going to be like, okay, you're going to do this. You're going to shade in the middle. Now, actually, this is an interval notation. This is just the interval. Interval notation is another thing. So when you have a bracket, this means less than or equal to, or actually, hold on. Yeah, this means less than or equal to, okay? When you have a bracket going like this, it means less than or equal to. When you have a bracket going like this, it means greater than or equal to, okay? I know that's kind of confusing, so let me explain. Let me just explain. If we're going from A to B, and we have this one here, this first one here, that means that there's going to be a bracket at A, right? And then going comma, and then saying, okay, and then there's this one, less than or equal to B. So then we're going to put B, right? We're going to put B, and then another bracket, because anytime you have something like this with the line under, it's always going to be a bracket. Even if it's like greater than or equal to, even though you don't really have those. Or actually you do, to be honest. This is going to be a bracket like this. So if you have x is less than or equal to b, it's going to be from left to right, right? So you're going to say it's less than or equal to negative infinity to b, bracket. It's a little hard to explain, you guys. I know. It's a little hard to explain, but it's how it works, right? You just really want to understand, like, the difference. Anytime you have this, so less than or equal to is just bracket. Greater than or equal to is just bracket. Less than is parentheses. Greater than is parentheses. And then this is closed dot, this is closed dot, this is open dot, this is open dot, right? Now, if we have A is less than or equal to X is less than B, this is from A, so we're going to say, draw a line, and we have a closed dot at A. So let's just say we draw the line, right? Let's just draw the line. and put a and b on the line, right? Now you're gonna say, okay, a is less than or equal to x. What do you use? If you have this, what do you use? Do you use a dot, or do you use a circle? It's gonna be a dot, a closed dot, right? Now, you look at b and you say, oh, it's less than. Okay, so is it a dot? Looking at this, looking specifically at this part, do you say, oh, is it a dot or is it a circle? Well, it's less than, so it's a circle. And now you just go ahead and shade in between. That's another way to think about it. Now, there are some, and in interval notation, one thing to think about it, one good way to think about it is if you have a closed circle, like you make a fist and you have a closed fist, and you look at the palm, you look at the shape of your hand from your thumb, like how it looks from your thumb to your index finger, and you look at it and you see how it looks like a bracket, right? So it's going to be from A, and then you do the open circle like this, and then when you do an open circle with your hand, kind of like the OK symbol, you see that it forms a little parentheses, right? It looks like a parentheses. So it's going to be to B, and then parentheses, right? That's a good way to think about it. That's how I that's how my Algebra 2 teacher taught me. Not professor, it was in high school. Anyways, we have a is less than x is less than or equal to b. This, so now we switched it, right? We have from a and then to b. So then we have a is less than x. If we look at our chart here, we have less than, that's going to be parentheses, right? And it's going to be an open circle at A. And then we look at B and then we say, okay, it's less than or equal to B, right? So it's going to be a closed circle. So now you just shade in between. It's that simple. Do not think about, oh, do I shade left, right, up, down? Like, don't think about it too much. When you have something like this, now unless they gave you something like x is less than or equal to b, or x is greater than or equal to a, or x is less than or equal to a, then okay, that would be different. But obviously, like, I don't even think they teach that until pre-calculus, to be honest. This, if now, just for fun, you don't have to learn this, but just for fun, if I were to graph this, it would be A and then B. So then you would have a closed circle here, and then you would shade right here. But then you also have a closed circle over here, and you would shade all of this. Right? But you don't have to know that, because I don't think they do that. Let's see, what other one? Which one am I missing? Oh, and in interval notation, oh yeah, and then in interval notation, this would be from, it would be parentheses a comma b bracket, because you know you have a closed circle here, you have an open circle here, so it's like this. This one is bracket, parentheses, and then this one is bracket, bracket, and then we have this last one that says a is less than x is less than b. This would just be like this, right? And then you would do parentheses, parentheses, right? Now, one of the things that I really want to reiterate to you guys and really like make very clear is that when we say the interval 1 to 3, this is not a coordinate, okay? Please do not mistake that for a coordinate. When we say the interval 1 to 3 with parentheses on both sides, that is not a coordinate. That means that we have, so if I were to do this, it's at 0, 1, 2, 3, -1, -2, -3. This means that if it's at this part here, right? And you're just shading in between. It's just from 1 to 3. It's not any other number, okay? I feel like there are people that do get confused when it comes to those. They think, oh, it's a coordinate, and no, it's not. Now, if I said the point 1 to 3, or the point 1 comma 3, then yes, this is a point on the coordinate plane. So I really wanted to just, you know, make that very clear. Now, if we have something like -2 is less than or equal to x is less than 1, and we want to write this in interval notation and plot it. In interval notation, notice that we have a less than or equal to x, right? So we are going to have bracket -2, and then comma 1, and then notice that it's less than, so it's parentheses. This one would then, if we were to plot it, this is 0, -1, -2. This is 1, 2. So basically, the way you would do it is we have a bracket at -2, so it's going to be a closed dot. And then we have, so just color code it. And then we have a parentheses at 1, right? Open dot. So then we're just going to go ahead and shade in between. Now, it doesn't have to be color-coded, because honestly, it would just be the same thing. But if I had like -3 is less than x is less than 1, this would be an open circle at 3, right? And then an open circle at 1, and then just shade in between. And this would be x, right? All real numbers x. Now let's say I were to do x is greater than or equal to 1, right? you would do a closed circle at 1, and it's greater than or equal to 1, right? This is infinity, this is negative infinity. Infinity and negative infinity just means, so infinity means that it goes on forever on the right side, on the positive side, right? It goes on forever and ever and ever, it never stops. Negative infinity just means it goes on forever on the left side, on the negative side of the number line, right? So it would be x is greater than or equal to 1, so it'll be like this, right? So then you ask yourself, you're like, well, how would you write that in interval notation, right? It would just be bracket, because it's greater than or equal to 1 to infinity, parentheses. Anytime you have infinity or negative infinity, you always use parentheses. Negative infinity and infinity always use parentheses. So let me write that down. Okay. So that is just how, like, that's just my explanation of, like, how to do, interval notation and types of functions and stuff. Like, basically, that's the first part that I want to go over, okay? So I'm going to stop this video here because I don't want to make it too long, but I will make a part 2 to this. If you guys like this video, please subscribe. If you find it helpful, please subscribe. I know I did go over a lot in this video, so I will continue later, and I will make a part 2 to this, okay? Thank you so much for watching, guys, and I will see you guys next time. Bye, guys.